So this is a quick example just showing how we calculate power and then how we can determine what the equivalent resistance is with the circuit. And so in this case, we have a component which they're calling COM or COM, which is right here. And you can see that it's connected to some larger system that we don't know much about, but we'll just call it RB. And they're saying that there's a current flow between COM and the system of 4 amps. And then if we take our voltmeter and measure across COM, we can see that there is a potential difference from each side of 12 volts. So the first thing they ask us to find is the value of the power supplied by COM. So here we just recall that power is equal to the current times the voltage. So in this case, it's pretty simple. This would be what they call IM times VM, where those values, again, or right here, IM and VM. So if we plug those values in, we would get 4 amps times 12 volts. And so when we multiply that out, we get 48 watts. So this is the answer to the first part as far as the power supplied by COM to our system. So next they want to know what the equivalent resistance would be here. And so again, we just need to go back to our definition, and this will be Ohm's law. So we recall that Ohm's law is just V equals IR. And so we want to know the resistance part, so we need to solve for R. And when we do that, R is going to be equal to the voltage over the current. And so in this case, again, that's going to be VM over IM. So when we plug those values in, we get 12 volts over 4 amps. And when we divide that out, we get 3 ohms. So this is the equivalent resistance associated with the attached source RB.